What if I told you that most AIs today couldn't plan a pizza delivery without messing it up? That's right, the same AI that can write poems and pass the bar exam falls apart when asked to get your groceries to your door on time. But what if that's about to change? Because what a team of scientists just unleashed might not only revolutionize logistics, it might give artificial intelligence something it's never truly had before: real-world common sense. The big problem. Everyone talks about how AI is revolutionizing everything, from art to medicine to the stock market. But here's the twist. Most AI systems fall apart when it comes to the kind of everyday decisions that make the world actually run. We're talking about scheduling delivery drivers, planning routes for trucks, coordinating shifts for hospital staff, or making sure raw materials arrive at factories just in time. These aren't just simple logistical puzzles, they're among the most complex computational challenges known to humanity. In the tech world, these are called combinatorial optimization problems. It sounds complicated, but here's the idea. You have a huge number of possible choices, and only a tiny fraction of them are truly optimal. Miss one small factor, and the whole thing collapses. Take this example. A logistics company needs to deliver 100 packages across a city with 30 drivers. Each package has a specific time window. Each truck has a limited carrying capacity, and traffic is always changing. The number of possible route combinations, it's more than the atoms in the known universe, and they need an answer, fast. And that's where AI has hit a wall. Neural networks, the kind of AI that powers your voice assistant or recommendation engine, just aren't built for rigid decision-making under constraints. They're great at finding patterns in smooth data, like images or text, but they struggle when the task requires binary decisions, like go here, but not there. On the other hand, traditional algorithms that can handle these kinds of problems, like constraint solvers and search algorithms, require perfect data and take too long to compute. In a real-time system, like dynamic delivery routing, you simply don't have that kind of time or information. We've been stuck in a deadlock: AI that's fast but fuzzy, or logic solvers that are accurate but slow. The world needs something that can do both, and until now, that's been out of reach. The tech limitation. So why exactly can't AI, with all its hype, solve these planning problems? It comes down to how neural networks work. They're like digital artists, amazing at capturing trends, patterns, and predictions in vast oceans of soft, continuous data. They learn by seeing example after example and gradually improving their guesses. That's why they're great for recognizing faces, translating languages, or suggesting the next video to watch. But when the task requires hard, rule-based decisions like don't go over the truck's weight limit or arrive at this address between 1 and 2 p.m., these AI models hit a wall. They're just not built to follow rigid constraints. On the flip side, you have exact mathematical solvers. These are like chess masters, slow, methodical, and they'll calculate every possible move. They're powerful, but they assume perfect, clean data and need a lot of time. Both luxuries you rarely get in real-world operations. What makes real-world logistics especially brutal is that it's dynamic and messy. Delivery requests change, traffic gets snarled, weather delays flights. The plan you made 5 minutes ago might already be outdated. What we need is a system that can plan like a solver, respecting rules and constraints, but think fast like a neural net. One that can adjust on the fly, make trade-offs, and still get close to optimal performance. This is where the breakthrough begins. The breakthrough. So what if we could take the best of both worlds? What if we could build an AI that's fast and flexible like a neural network, but smart and strategic like a planning algorithm? Well, that's exactly what a group of researchers at DeepMind have done. And the heart of their approach lies in something called MCC Layers, which stands for Markov Chain Monte Carlo. Don't worry about the technical name. What matters is the concept. They've given AI a new way to explore options intelligently. Think of it like this. When you're trying to figure out the best route to drive home, you don't check every possible combination. You test a few ideas in your head. What if I take the back road? What if I skip Main Street? You mentally simulate different tweaks until something clicks. MCC Layers let AI do something similar. Instead of searching randomly or relying purely on guesswork, the AI now makes strategic, small changes to its current plan just like a human would, and then checks if those changes lead to improvement. This allows the AI to adapt in real time, make good enough decisions under pressure, and even learn from trial and error. And because it's embedded inside a neural network, it stays fast and scalable. This isn't just an upgrade, it's a paradigm shift in how AI makes decisions. How it works. Let's break down how this works, using something we all understand: planning a road trip. Imagine you're visiting 10 cities in a week. You want the shortest, most efficient path. There are hundreds of ways to arrange your route. Do you go from New York to Boston first, or New York to Philadelphia? Now imagine an AI that can simulate every tiny tweak, like swapping the order of 2 stops or rerouting through a new highway, and instantly calculate whether it saves time, fuel, or both. That's what MCMC Layers enable. This AI doesn't try to brute force every answer. Instead, it learns to explore nearby options intelligently and choose the ones that move it closer to the best outcome. The technique it uses is inspired by a process called simulated annealing from metallurgy, where metal is slowly cooled to remove imperfections and become stronger. In this case, the AI cools down its choices over time, locking into better and better plans. What makes this special is that the AI isn't just guessing, it's learning. It uses scores to judge its changes, gets feedback on how close it is to the optimal route, and continuously refines its strategy. It's like having a seasoned logistics manager built into a neural net, one that learns faster than any human could and never sleeps. The results. So, how well does this actually work? Researchers put it to the test on one of the hardest challenges in logistics, the dynamic vehicle routing problem with time windows, or DVRPTW. This is a real-time, high-stress scenario where delivery requests show up constantly. The AI has to assign trucks, plan routes, respect time windows, avoid overloading, all while the situation changes second by second. Using their new MCMC enhanced system, they gave the AI just 1 millisecond to come up with a plan. 1 millisecond. In that blink of time, the AI generated solutions only 7.8% worse than the perfect plan, a theoretical model that knows every delivery request in advance. By contrast, older methods that relied on random tweaks, called perturbation techniques, were over 65% worse. Even when given more time, like 1,000 milliseconds, the MCMC method stayed competitive, showing it's not just fast, but scalable. It's like giving your GPS 1 second to reroute after an accident and having it still nail the best path. These are real, measurable, game-changing results. Real-world impact. Now, let's step back. Why does this matter beyond logistics? Because efficient decision-making is everywhere, in hospitals, emergency response, city traffic, factory floors, classrooms. Imagine a hospital using this AI to schedule surgeries, optimize use of operating rooms, and ensure doctors aren't overbooked. Or imagine a smart city using it to time traffic lights, reroute buses, or coordinate snowplows during a storm. This kind of AI won't just make businesses more efficient. It could make lives safer, healthier, less stressful. It's a step towards AI that actually understands the messiness of real life and helps us manage it better. Pattern interrupt. And hey, if this AI ever figures out how to plan a cross-country family vacation with 3 screaming kids, 2 dogs, and a budget under $1,000, we'll go ahead and nominate it for president. But jokes aside, let's zoom out again, because the implications get even deeper. The future. This system is still in development, but the building blocks are here. And the next big leap? rolling it out into live environments, from package delivery fleets to public infrastructure systems. Because when AI can plan better than humans, when it can juggle thousands of variables in real time with near-perfect precision, that's not just a new tool. That's a new kind of intelligence. One that doesn't just respond to the world, it organizes it. So here's the question. If AI can now plan your deliveries, your surgeries, your commutes, what won't it be able to plan next? We're witnessing the rise of a new kind of intelligence, one that's not just creative or powerful, but practically useful. And that's the kind of AI that will change how we live. So, what would you trust in AI to plan for you? Your commute, your surgeries, your life? Let me know. And if you want to stay ahead of the future, hit subscribe, because what's coming next is even smarter.